afternoon, everyone. Good, you're not all asleep. It's actually a tough act to follow, the whiskey panel. So I'm glad there's still people in here. My name is Ben Klang. I have a company in Atlanta called Mojo Lingo. We build voice applications that work like magic. And I'm also the leader of the Adhesion Project, which is why I'm here to talk to you today. So before I get started, how many of you have heard of Adhesion? Very nice. Okay, how many of you have tried it? Right, okay. And anyone have it in production? Yeah, cool. All right. So a lot of you have heard of it. Looked like not all of you have tried it. Let me just briefly go through what Adhesion is. So Jay Phillips, the author of Adhesion, called it adhesion that you can hear. It glues the voice layer to the rest of the world. It is a voice application development framework. You all in here are familiar with Rails. So Rails is a framework for developing web applications. Adhesion is a framework for developing voice applications. Provides a lot of that same nice functionality that you need, things like logging and demonization, a plugin system. Really lets you focus on building the voice application as opposed to all of the other stuff. It is, of course, open source and runs on Ruby. We provide functionality to easily integrate with Rails, but it is not dependent on Rails. It's a totally standalone project. Integrating with Rails is obviously a great thing. We can automatically load all of your helpers and your models, so you can reuse a lot of code, but you don't have to. It's platform agnostic, runs anywhere Ruby or JRuby does, which is really nice, especially for enterprise people who are kind of stuck on the JVM. JRuby is a great target for it. It runs fairly small. It's not a heavyweight framework, but it can scale pretty large. We've personally seen, in my experience, hundreds of concurrent calls in a single Adhesion instance. And usually what happens is the telephony platform is the limiting factor. We haven't actually run out of Adhesion resources yet. And it's cloud ready, which is kind of a buzzword, but I'll talk about what that means in just a minute. So usually when I tell people that I build voice applications, the first thing they say is, that's cool, but what do you do with it? So this is just talk a minute about some of the ways you can actually use this. Adhesion is, one of the great ways to do it is call center workflow. So almost every business has some need to take calls from their customers. This can be the two guys at the startup who just need to handle customer service, all the way up to a professional call center of 500 seats, whatever. The thing they have in common is they really need to have contextual information about the people they're talking to. And one thing Adhesion can do is tie in things like your CRM, whether that's something you have local or something in the cloud. It can tie in your issue tracking system, your finance system if you need to know whether an account is current. And you can present all this information in real time to the person taking the call. You can do that through a web application. You can do that through maybe an instant message. But the point is that it really brings in these two normally separate, disparate systems and brings them to a single unified application. Pretty cool. The same would be largely true for things like Salesforce automation, keeping track of customer relationships. So for example, when you're calling out to a customer, you want to keep notes of the call. You could, for example, record the call and let the sales agent type notes as he goes and then correlate those after the fact. So there's really, really cool applications mixing the different technologies together. In the startup world, we're seeing some pretty cool conferencing applications. Anything from finding a person who needs help and connecting them with an expert who can provide that help, or chat applications like text messaging that you can then bring everyone who's on that text message bridge into a voice conference, again, multimodal. The classic place is IVR, interactive voice response. If you don't know what IVR is, it's that really annoying thing when you call your bank or you call the airline and it sends you to an infinite loop. Well, with Adhesion, you can do that, but not be annoying. And other use cases would be polling, so political candidates, or robocalling, things like calling to remind you that your prescription is available. Now, these are the kind of bread and butter of Adhesion. This is what we do kind of day in and day out. But this isn't all you can do. One example is has anyone here heard of the AR drone? It's made by Parrot. Okay. If you haven't heard of it, it's a four-bladed helicopter. And it flies. It's this big. And they provide all of the documentation on how to interface with it. So I wrote a library called ARB Drone that sends the packets to actually send the control inputs to it. And what you can do using Adhesion is actually call into my phone system and fly the helicopter using a telephone. It's totally useless, but it's really cool. Another example was an art project. There was a couple artists in Montreal who, I forget the name of the show, but they actually projected on the side of a building, 8 stories tall, music staffs, and had people just walking down the street be able to call into this thing and interact in real time, press buttons, change the way the music was being played. The music was coming out over speakers in the courtyard. And that was done with regular telephones. So anybody walking down the street could participate in this giant public art experiment. Those are examples of thinking outside the box. And there are a lot of things that haven't been thought of. So this is a pretty exciting place to be where really the sky's the limit. So I'll talk for a minute about Adhesion's platforms. There are lots of ways you can connect into Adhesion. From day one, we've supported Asterisk. I'm guessing that most of you in here have heard of Asterisk? Yes? Okay. Well, if you haven't, it's an open source PBX. Using Adhesion and Asterisk, you have an entirely open source stack. Everything to get the call in and handle it can be done open source. Most of the deployments of Adhesion today are still on Asterisk. Last year, Jason Gecky added support to Tropo, which, if you've heard of Tropo, it's a competitor to Twilio. They are both cloud-based communication services. Tropo is actually a sponsor of this conference. And you can use Tropo to connect into Adhesion and handle your calls that way. I think one of the best arguments for Tropo is, especially for people who aren't familiar with telecom, it can be a challenge to set up. I'm being a little bit subtle there, but with Tropo, you can go to the webpage, sign up for an account, allocate a phone number, and within 5 or 10 minutes, you can be processing calls through Adhesion. So it's a great way to get started if you're looking for something simpler and don't want to go through the hassle of setting up your own Asterisk. This year, we added support for a new platform called Prism, and Prism is kind of at the other end of the scale. It's an enterprise-grade system. Prism has been known to scale up to as many as 5,000 concurrent calls, so it's really a different class of system. We are targeting full Prism support for Adhesion 2.0, which is due later this year, but that really gives a nice range of platforms. So you can prototype your app on Tropo, you can migrate to Asterisk if you need to keep something in-house, and then go all the way up to Prism with little or no changes to your code. So it's a very flexible platform. Also talk quickly about the architecture of Adhesion. At the top, you have the 3 telephony platforms. These are the ways the calls get into your application. These are where the phone numbers ring. So the call goes in, and then the platform, Asterisk, Prism, or Tropo, will make a connection into Adhesion. And then Adhesion, you can do things like answer the call, hang up the call, transfer the call, all the things that you would need to do with the call. Adhesion then has built-in support for SQL databases using Active Record, for LDAP using Active LDAP, for XMPP and Jabber, which is actually really cool. You can mix in presence information, so you can know if someone is at their desk or they've stepped away before you even send them the call, or you can send them a message. And of course, anything Web 2.0, anything that has an API, you can, for a lot of you out there, I'm sure you're web developers, so being able to access web APIs is probably second nature. And again, this is all Ruby, so if you need more functionality, there's more than likely a gem for it. Just install the gem. You can bake that into your application. So I'm guessing that some of you out there, especially those of you who didn't raise your hand when asked if you knew what Asterisk was, have this feeling about telephony, that it's hard. And Adhesion can make it a lot less hard. So to kind of reassure you a little bit, I'm going to put you back in the comfort zone. It's Ruby code. It's easy. Adhesion provides a DSL, domain-specific language, and you can do things like answer. If you want to play a text string and render it through text-to-speech, you just say speak, and you pass it a string. You can see on the third line, we're looking up the caller ID, finding out who that person is, looking up their record in the database, speak another message to them, and then dial. So it's very easy to read. It's very Ruby-ish, if you're familiar with that. All right, so the name of this talk is Evented Telephony Applications, Telephony Application Design. So let's talk about why Evented. Telephony needs are very well modeled by evented design. Unlike a web page where you have a single load of telephony, a telephone call lasts for an amount of time. You've got interactivity for that whole time. Many events come out of that phone call. For example, key presses, DTMF. Every time the user presses a button on their phone, we will raise an event within Adhesion, and you can react to it and do something with that event. Anytime a new call comes into the telephony platform, you'll get a new call event. Anytime that call changes state, so if it goes from ringing to answered, or answered to on hold, or on hold back to up, and then to hang up, you'll get events for each of those and be able to react to them, update billing, whatever you need to do as the state changes. You'll also get events for joining and leaving conference bridges, for callers entering the queue, being connected to an agent, Also interesting are in conferences are active speaker notifications. So if you're building a web application that needs to be able to see which callers in the conference are actually speaking to make for a nicer user interface, you can get events for those as well. So what all this does is it allows you to write the main body of your code in a linear fashion, something that's very comfortable and familiar. But you can add extra functionality without interrupting that flow. So for example, in the example of a conference, when the caller joins the conference, that's a blocking call, right? So the code is going to pause at that point, and it won't execute anything after that point until the user exits the conference. But let's say, for example, you want to allow them to press 0 to reach an operator, or press star to leave the conference. You can use an event to capture that DTMF and then take the caller out of the conference or transfer them. It really makes that a lot easier. You can also react to external events. So for example, if a timer expires, if this is a calling card application, you can terminate the call and tell them their balance is out and they need to re-up it. Or if you're building a queue, you can react to an agent becoming available and then transferring the call, taking it from on hold and sending it to the agent. So evented makes a lot of sense in the telephony world. So now what I want to show you is how this actually looks in code. Pull my notes. All right, so the first thing we'll do, I have Adhesion installed. I'm not going to go through a gem install. I'm sure you've all seen gem install before. The name of the gem is Adhesion, so just install that gem. And since it's a framework similar to Rails, we're going to create a skeleton application. Oh, sure, thank you. How's that? More? All right. Good? Okay. All right, so we're going to create a gem. We're going to create an Adhesion project, and we'll call it RubyConf. So this will lay out the skeleton of your new application. And you can see it created a bunch of files. We'll go into the RubyConf application. The first thing we'll need to do is tweak the configuration. The generated, let's do this. How's that? Is that readable? Okay, good. The generated configuration comes with lots of comments. I'm not going to go into all this right now. I'll be happy to answer questions afterward. There are a couple things we want to do for the purpose of this demo. I'm going to change the log level to debug, just make it a little easier to see what's going on. And I'm also going to tweak the configuration for the version of Asterisk that's running. Unfortunately, we try to detect as much of this as possible. There are some limitations of the Asterisk platform that you have to actually configure, so it's important to check this file whenever you generate a new project. The other thing I did here is I uncommented the line that says enable AMI. So in the Asterisk world, there are two interfaces to dealing with the call. You have AGI, which is the gateway interface. That's what allows you to do interactive control, things like play a sound file, hang up a line, dial out. That's interactive. AMI is the manager interface that allows you to take those events asynchronously. So the two can work together. To enable events, you need to uncomment the AMI line here. Of course, as username and password, I've just got it default for now. In the rest of this file, there are other things that you may find interesting. For example, DRB. If you're familiar with distributed Ruby, it's an RPC mechanism. We use DRB a lot, actually, to enable things like click to call. If you have a Rails application and you want to enable the functionality of a user to click something on your site and receive a phone call, DRB would be a good way to do that. You can also enable Rails integration. This is what I mentioned earlier, where it will load in your entire Rails environment. So you'll get access to all your helpers, all your models, all that code you've invested. Why not reuse it, build it into your telephony app? You also have access to, if you're not using Rails, you can enable Active Record directly, so you can load those database models. You can enable LDAP and XMPP, as I mentioned earlier. So those three changes there are the log level and the enabling asterisk. I'm going to leave those. That's all we need for now. Next thing we want to take a look at is the dial plan. So the dial plan, this is where calls will initially come in when they hit your Adhesion application. These are little named blocks. You can actually route calls to different blocks. In this case, we're just going to use the Adhesion block. The example starts a Simon game, which is a little game you can play on the telephone. But what I want to show you is we're going to basically answer the line and drop the caller into the conference. So we'll answer. We'll play a sound file. So the caller will hear you are now being placed into the conference. and then we will actually drop them into the conference application. And we'll join the room RubyConf. Now, that last line, that execute, is blocking, as I mentioned. You're not going to go any further until the user exits the conference. So I'll just drop a log statement here. Of course, that won't appear until the caller exits or hangs up. Yeah, did you have a question?
Yes, you set up the adhesion side, but you're making the assumption that on your Asterisk server, you have pointed that out to come here.
I'm sorry, that is a good point. So you do have to also configure Asterisk to load the adhesion app. Let me jump over to what that looks like. So this is a little bit beyond the scope of what I was planning to do today, but it is a good point. Extensions.com. You can see at the end there, we have all the calls routed to AGI. This is what actually sends the call from Asterisk into adhesion. The Asterisk setup is a bit beyond the scope of this talk, but we do have on the adhesion website and on the MojoLingo blog, we have screencasts and examples to help you get to this point. It's also interesting to note that some of this stuff does not apply at all when you're using Tropo, because that configuration isn't required. But it is a good point. Thanks for mentioning that. OK, so we did look at dial plan. We have those 3 lines. So now let's take a look at the evented side of it. We're going to have events.rb. So this is the skeleton events.rb that you get when you generate a new app. The first thing I want to do is pull in a class. Use something I prepared earlier. So this is a class. Now, it's important to note that you are writing threaded code. So you'll need to take care to make sure that you don't do anything that's going to break in a threaded world. What we're going to do here is create a class called conference. And this will be used to manage users entering and leaving the conference. We're going to include singleton, so there's only one instance of the conference at any given time. And when the conference is initialized, we'll keep a list of the participants. This little piece at the bottom is just a little syntax sugar, so we can not have to call instance on it. So the next thing I want to do is pull in a couple methods that will handle what happens when a user enters the conference or leaves the conference. The first is add participant. And we're going to call it with the channel ID. And again, that synchronized block is a mutex to make sure that we don't accidentally have 2 threads trying to add to the same array at the same time. Avoid that race condition. And the same is true with remove participant. We want to pull them out of that array. The next thing we want to add is a bit of code that will play a sound. So we've got a list of the participants in the conference bridge at any given time. Now we want to be able to play a sound file to them. This will go iterate over that list and add a log message saying that we're playing a sound file to the channel, and then actually send the event to Asterisk to play that sound file. So now we have the code to actually do these pieces. Now we need to add some code that will handle the events coming out of adhesion. All right. So we're going to have events. Do this. Events.manager or asterisk manager interface each. So this block will be invoked each time an event is raised coming from asterisk. We'll call that event. All right, so the first thing we'll do is grab a handle on the manager interface. That's what we'll use to send commands to the asterisk server. We'll grab the channel. So the event has several headers that include the channel, the caller ID, the unique ID of the call, things to help you figure out what event and what channel you're dealing with. And then we have a case statement to determine which event we've received. So I've got 2 added here. The first is conference join. We will get that event each time a caller joins the conference. And the next one is conference leave, which we'll get every time the user exits the conference. All right, so that should be enough to test. So let's pull up the app. This is a Blink, which is a soft phone. We start asterisk. All right, asterisk is up. And let me place the call. So if we, I need to start adhesion too. That would be important. So I've got adhesion running in one window and asterisk running in the other. we care more about adhesion than asterisk right now. So when I call the conference bridge, what should happen is first the dial plan will execute, so we'll get the message you're about to be placed in the conference. You'll then join the conference. What will then happen is asterisk will send an event to adhesion, and we will get the conference join event. And if we did it right, we'll also hear a sound that sort of sounds like a clanging of pans that you've entered the conference.
You will now be placed into the conference.
And there you go. So that's just a conference join event. The conference application that I'm using does not include any sound effects by default, so that's actually a good way to let people know that people are entering or leaving the bridge. Yes, you have a question?
Yeah, basically, this is mostly command and control that you're teaching us right now, but what part of the API handles the text-to-speech? A, is it dictionary-based? And B, how does it handle IATN, where you've got different languages?
Okay. If you don't mind, let me cover that in the Q&A at the end. The questions about text-to-speech, I'll be happy to get to that. Okay. So the recording you're going to hear right now is all pre-recorded, just for the record. It's not text-to-speech at the moment. Okay, so we've got the call in the conference. It's kind of boring. I'm guessing you guys have heard of soundboards on the internet, like the Chuck Norris soundboard or the Terminator soundboard, a way to play funny sound files. So let's do one of those. All right, the first thing we're going to do is add another event handler. So this is going to be the DTMF event. Every time the caller presses a button on their phone, we want to capture that and react to it. So the DTMF event, you get two. You get one on the beginning of the DTMF. In other words, when the user presses the button, in other words, starts pressing the button, and then when they let go, you get a second. That's important because if in the example of the helicopter I mentioned earlier, to fly the helicopter, I determine how long the helicopter is tilted by how long the button is held down. So the timing of the events can be significant. In this case, we only care that a button was pressed, so we're going to capture one of the events. In this case, you can see in the if statement here, we want to look only for end events that are set to yes. The other thing we care about is that we get the digit out of the event. So that's sent as part of the header sent from asterisk. So now that I've got that method, let's define. We've asked for a play for DTMF method. Let's go make sure that method is available in the conference class. Actually, first let me grab the list of sound files. All right, so we've got 6 hopefully humorous sound files here. And I'm going to pull in also the method to play DTMF. All right, so play for DTMF is just a real thin wrapper around play sound. It's going to map the digit that was pressed to the audio. Yes?
They're thinking, so can you capture the while you're pressing, or you have to press, then release, and then you measure that?
Okay, so the question was, can you capture the information while it's being pressed?
Right.
Yes,
okay.
You can. So the first event you will get from asterisk is when the button goes down.
Okay.
And while the button is down, you've received the event. Mm-hmm. The next event you'll get is when the button comes up. So you'll get both. In this case, we're only looking for the end event, but you could look for the begin and do something while the DTMF is coming in.
So you're executing the code, and then when another event comes in.
Right, so in the helicopter example, when the begin event comes in, I tilt the helicopter forward,
Right.
and when the end event comes in, I put it back. In this case, we only care about the end event because we only want to know that a button was pressed. So I've added the event handler for the DTMF. I've added a method that will play the sound file. So let's test this. I do need to restart adhesion because I've changed the event handlers. So I've restarted it.
You will now be placed into the conference.
All right, so we have a list of sound files here. Does anyone want to pick which one we're going to play first from this list? Just shout it out. Weasels. Whoops. Weasels are good. What's that, 1?
Weasels have eaten our phone system.
Any others?
Monty Nights.
What's it? 6? Everybody loves monkeys. I should have mentioned it's a long one. All right, let me come back to that. So you can see here, we'll come back to 5. You can see here in the log, we got our event. You can see the channel that triggered the event, so we know who to blame for playing monkeys at us. We can see the unique ID of the call, which may be interesting for logging purposes. You can see which digit was pressed. In this case, the DTMF was coming to us as opposed to sending DTMF out. And you can see here they begin and end. In this case, this was not a begin, this was an end. So that's an example of just using DTMF. Now, let's see how to view. So you can see an example of, I've only picked 3 events here. You might be wondering what other events are possible. There are 2 ways to answer that question. One is the documentation. If you go to wiki.asterisk.org, you'll be able to see a whole list of various applications that generate manager events. But sometimes even that's incomplete. So the one easy way to see what's going on is to actually go back up to this event handler and just log. In this case, I'm going to log the name of the event coming to. Every event that comes in, I'm just going to log it at the info level. Received event name. All right, and I'm going to turn up the logging to info just to make it a little quieter, and we'll try this call again.
You will now be placed into the conference.
Oh, I have to restart adhesion. Okay, so the first one you can see is we received a fully booted event that lets us know that Asterisk is ready to take calls, which it already was, but it sends it to us anyway.
You will now be placed into the conference.
All right, so we have a bunch of interesting events here. We have new channel, which lets us know that a call has come in. We have some var set, which is an internal Asterisk channel variable. We have new state, which is telling us that we are transitioning from ringing to answered. Actually, that's transitioning to ringing, and then we have another one here that's transitioning ringing to answered. We have an event here that the caller joined the conference. And another event here, so we played that sound file, that CAN-sounding sound file. When that completes, the conference bridge sent us another event saying the sound file is complete. So if you needed to play another sound file, you could do that. These other events here are internal to Asterisk. In this case, they show us call quality information. So what was the other event you wanted to, was it 5, you said? 5? All right, let's play 5.
Go and boil your bottoms, you silly English knickets. I fart in your general direction. Your mother was a hamster, and your father smelled of elderberries. Now go away, or I shall taunt you a second time.
Can't go wrong with Monty Python. Yes, a question.
Can you filter the events that you're getting from Asterisk, or is it all or nothing?
So, right, so the question is, can you filter the events that are coming from Asterisk? As of today, well, there are 2 answers to that question. Asterisk does allow you to put filters on the events you subscribe to. Adhesion doesn't expose that. We'd rather get all the events and filter it in our code. As of Adhesion today, Adhesion 1.x, you basically do it in that case statement that I showed you. So what I typically do is I have a case statement that dispatches to the various methods that do whatever I need to for that event. And
as you scale to say hundreds or thousands of concurrent calls, will the number of events become a problem if you're listing all of them?
So will the number of events become a problem as you scale? And yes, it is possible. So there are different strategies. You can, as I mentioned, filter the events based on, if you need to, you could have multiple adhesion servers and have this one only handling certain types of events. There are different ways to deal with that. Also, in Adhesion 2, we will add the ability to do guards, if you're familiar with Erlang. It's something Blather does as well, so you can subscribe to certain types of events and just not enter that block at all. But right now the answer is you pretty much do it yourself in code.
How different are they going, like Asterisk or Trovo or Prism? Reuse the same code?
Yes, so the question is, how different are the various platforms, Asterisk versus Prism versus Tropo? If you don't mind, let me come back to that one, because that's a good question. All right, so we've got all the events. Oops. We've got all the events that are coming from Asterisk, so you can very easily see which events it's throwing out. There are a few events that are also generated by the framework itself. They're documented here in the generated events.rb. Those are, for example, events.exception. So every time your application hits an unhandled exception, it will raise this event. This is helpful. For example, this is what we use to send exceptions in our application to Airbrake. We attach a event handler on the exception on the exception events and then send it off to Airbrake's API. There are other events. Manager interface is the one we just demoed. After initialized is called after the adhesion framework has finished booting. It's connected to all the backends. It's ready to process calls. You can use that to do something if you need to. Events.shutdown is the opposite. As adhesion is starting to shut down, you'll get this event. asterisk before call and after call, which isn't mentioned here. When the call comes into asterisk after the call is connected to adhesion, but before the dial plan code starts executing, you can do something with that event. The failed call is when a call has been generated to go outbound. So the way that works is we tell asterisk to place a call, and then when it connects, it sends the call into adhesion. If that call fails for some reason, if it doesn't answer or it gets a congestion or a busy signal or something, then the call will never come into adhesion. So that event will allow you to handle outbound attempts that fail. And then hung up call, of course, is triggered whenever a call hangs up. Okay, so these are the building blocks for evented design. As I mentioned, I think the real power comes from combining evented with the procedural code you do in dial plan. If you're interested in more information about all of these things, we have, well, two things. The first I want to tell you about is AdhesionConf. Next week, the 8th, 9th. It's 2 weeks? 1 week? 1 week. Next week. I've lost track all time. Next week is AdhesionConf. Thanks again to our sponsor, Tropo. AdhesionConf is a free event. If you can find yourself in San Francisco next week, I think we have something like 20 seats left. So if you're interested, definitely come out. I'll be there. The entire Adhesion core team will be there. We will have presentations from people doing interesting things with Adhesion. Should be pretty cool. And I also want to mention that our website, adhesion.com, has links to documentation. Our wiki is there. Our mailing list is there. IRC. We have a really good community, and definitely if you have questions, we'd like to help that out. Also, the Mojolingo website, our blog has a lot of tutorials, screencasts, things like that that'll help you get started with Adhesion. So let me go back to the questions. I know there were two of them. The first was about text-to-speech. Okay, so the answer on text-to-speech is it is platform dependent. You asked about things like internationalization. So for example, Tropo supports 24 languages. Is that right? 24 languages. You have to declare which language you want, and you have to pass in the localized string. But Tropo support, you'll be able to do text-to-speech generation in 24 languages. So the question is it dictionary-based or phonetically-based? And I don't know the answer to that.
It is synthetic, but it's amazing how far text-to-speech is. I used to work, I did it at the same time Dragon was doing it, and they had 20 programmers, and I had one. It's phenomenal, and you can still do SSML, which is the speech program language. Yes, with prosody, inflection, speed, grammar, and the pitch inflection has gotten much better.
So the answer is it's synthesized, and Chris also made a good point. It does support SSML. So there's a companion library called Ruby Speech that will allow you to generate SSML documents, which is speech synthesis markup. You do it in a Ruby way. It's actually inherits from Nokogiri. So you can generate these documents that will allow you to control how the text-to-speech is generated, control the prosody, which is the rate of speech, the inflection, the gender, all these things. And then I had one more question over here. Remind me your question. Right. Okay, so the question is, really I think it's a question of how the different platforms are supported by Adhesion. The code is your code portable across platforms? Today, mostly yes. The notable exception is events. With Adhesion 1.0, the only real platform that supports events properly is Asterisk. Partly that's because Tropo today does not have an eventing model that works this way. In Adhesion 2.0, which is targeted for later this year, the eventing model will be unified between Asterisk and Prism, and actually Tropo will eventually also be running on Prism. So all three platforms should have uniform event support across all three. Now there will always be cases where platforms have support that others don't. So for example, today Asterisk supports video calls and a primitive video conferencing bridge. Tropo and Prism won't. If you want to use that functionality, you can, but you just have to know you won't be portable. And we'll have documentation to help you figure out where that is. But for the most part, I would say 90% of applications can be ported without any code change, at least today between Asterisk and Tropo. Okay, so the question was how is the application laid out so you can add pieces on, and where the various pieces belong within the application. And he makes a good point. I did put everything in one file. That was really just for simplicity. Normally what you would want to do is have a subdirectory, maybe a library directory, and put libraries in there that you can invoke from whether it's dial plan or events, and load them in. There's not a library directory here, just because I haven't created one yet. The other answer is components. So components are a plugin for Adhesion. and they're redistributable. You can get them as gems, or you can copy the directory into the Adhesion application. So a component, let me show you an example component. The one it comes with a Simon game, for example. So Simon game, at the very top, we have methods for dial plan. So this says that this component is only to be used in the dial plan context. That's because sometimes something that makes sense in a procedural world doesn't make sense in an eventing world. So in this case, Simon game is only meant for dial plan. And then what that does is it just invokes a new instance of the Simon game class and runs it with the start method. So then down here you have the Simon game, all the various methods that go with it. And by putting it into a component or by putting it into a library, it makes it possible to test. So we're big on test-driven development. So all the stuff that we write, we have to have a way to test. And components are a good way to do that, as are libraries or helpers. Dialplan.rb currently is not testable. So really the purpose of dialplan.rb is to help people who come from the asterisk world who aren't really Rubyists. We're going to be looking at ways to simplify that for Adhesion 2, but that's not totally fleshed out yet. You had a question over here?
Yeah, are there any projects like on GitHub that show the integration with CMU Sphinx?
So the question is, are there any projects on GitHub that show integration with Sphinx? Not that I know of. I can tell you that so the Ruby speech library that I mentioned earlier will generate SSML and grXML. Sphinx, for those of you who don't know, is a speech recognition engine, an open source one, done by Carnegie Mellon. And you need to, so Asterisk doesn't support it out of the box. You'd have to compile that and integrate it. Unfortunately, I don't know of any other box. Yes, question?
So I know you guys are working on some experimental free switch support at one time.
So the question was, at one point there was talk of support for FreeSwitch in Adhesion, and how is that coming along? The blunt answer is that we haven't had a project that needed it yet. But there is good news. So part of the work that we've done with Adhesion 2.0 has been, Adhesion 1.0 was really very asterisk specific. In fact, the way Tropo supports Adhesion 1.0 is to emulate asterisk. It actually has an AGI emulation layer. That's not ideal. So for Adhesion 2.0, we've actually restructured a lot of the internals and gotten rid of the specific asterisk dependencies. And we've separated it into two layers. Adhesion, the framework, will remain the framework for building voice applications. It's the easy way to get that high-level functionality. We've abstracted all of the lower-level platform support into a library called PunchBlock. And PunchBlock will allow you to talk to, today, Prism, Tropo, and Asterisk. And because we've done that hard work of, right, so FreeSwitch support, we're optimistic, should be a lot easier to add now. But we would like to support FreeSwitch. We just haven't needed it ourselves yet. Yep. So any other questions on this? No? Okay. Well, as I mentioned, the Adhesion website is a great resource. And if you have any other questions, don't hesitate to contact me directly. And thank you.